Welcome to part 3 of Competency 3 practice. In this video, we will work with vectors and matrices. Number 1, what is the determinant of the matrix y equals -2, 6, 4, and 1? Okay, we can put this in the calculator. First, we find a matrix A and we put our y in. Okay, let me show you what we do. We say second matrix, which is the x to the -1. See, it opened up, but it's not populated with our numbers yet. So arrow over to edit. A is a 2 by 2, so you push enter. But the 2 by 2 doesn't have the numbers we need. So let's populate those numbers. So -2, enter, 6, enter, 4, enter, 1, enter. Okay, now everything is good. Now be careful. If you push anything or go to any other function right now, it will place it in that cell. So you have to say second mode to back out, okay? Now let's go second, back to matrix, because now we don't want to push A. We don't want to push it. What we want to do is set the function up. And we need this highlighted DET for determinant, okay? So press enter. So now you got to go back and actually capture the A where we put our values, our y equal values we put in A. So say second matrix. Okay, now you push enter where it's highlighted, close the parentheses, place enter, and B is the correct option. Now notice that the determinant has a value, and that's going to lead us to number 2. If the matrix 5x -2, 3 does not have a multiplicative inverse, what is the value of x? This means that I can set it equal to 0. Okay? Up here for number 1, it is not equal to 0 because it has a value of -6. If it does not have an inverse, a value like number 1, then it's going to equal 0. And then that's when we say, hey, this does not have a multiplicative inverse. Or our calculator simply gives us an error. Generally, it should give you an error. So because we know that it is invalid, we have the ability to set it equal to 0. Now, take in mind that we have, oops, I want to do generalities here. So this is A, B, C, and D. Okay? So we know that this determinant, let's say this equals A, the determinant of our A equals A times B minus C times B. Okay? So that gives you an idea of exactly what to do. So what are we going to do? We're going to say 5 times 3 minus 2 times x equals 0. Okay? All right. That's a minus. All right. So we actually have 15. Oh, well, here, let me do a little bit better job with that. I can do better than that. This means we have 15 minus, actually, a minus times a minus is a plus 2x equals 0. So I see 2x equals minus 15, and you divide both sides by 2, and this yields what we need. Okay, now let's go over here and take a look at what we have. Well, A is positive, but I do believe that's misleading. Because if we pop this into the calculator, or if you can do it in your head, B is our option. Obviously, C and D are not going to be it. So if I say negative and alpha y equals, number 1's what I want, and I put in 15 over 2, push enter, Okay, I'm going to have to go back and let me see. I'll have to go to alpha y. Now that I have it entered all the way, then I want it in the form of 3. See, 3 goes back and forth. Now, if I pick number 2 to be a new setup, I don't want a new setup. I want number 3, so it'll take what I have and put it into mixed number. So push enter, enter again. There you go. It is obviously option B. It's verified. Okay, let's look at number 3. All right, all the way up. Okay. What is the product of 5 times the matrices 3, 7, negative a third, and negative 2? Okay, you can do this in your head. You do it component by component. So 3 times 5 is 15. Well, this won't work. The others will. Now let's go to the next one. So we did 3. Now 3 times 7 is 35, and it's a positive 35. Well, this won't work. This works. This works. This works. So the other 3 still work. Okay. Well, the proof is going to be in the last 2. Well, I'm going to say 5 times negative 2. Well, that's negative 10. Okay, so B still works, but C is out. So we have 2 fully eliminated. Okay, so we still have 2 in the works. Now, 5 times negative 1/3. Well, a positive times a negative is a negative. So we're looking for a negative value. So obviously D will not work. But either way, 5 times 1 is 5. So that is 5 over 3. That's a negative 5 over 3. So B works. Now, let's say those numbers are huge. Okay, let's enter it and verify again. How would you do that? Right. So notice that the 5 is in front of your matrices. That is the safe way to do this. That's your safe manipulation. Matrices are really picky about adding and multiplying, adding, subtracting, and multiplying, and how you divide and how it's done. You're not always going to have the commutative properties, and you will not always have, in fact, you do not have the associative property. It is not valid. I mean, I think there are some very rare cases that can be found, but don't depend on these things. So order matters huge, huge, huge. You must always make sure you have things in the correct order. And we'll get to something like that in a moment. Okay, so let's go second matrices. All right, I'm going to arrow over and edit. Okay, it's still a 2 by 2. But I want 3 enter, 7 enter, and then I have a negative, but I need to put in a fraction. So alpha y equals 1. Okay, now we're set up. So I do 1, arrow down, and put in my 3. Now I enter. Be careful when you enter. So now I need negative 2 and enter. Okay, so we're all entered and we're set up for that. So this is what I need to do. Remember, back out all the way. Okay, now I put in my 5 and my times, and I'm going to enter it exactly how it's written because that's proper. Okay, so I say second matrix. Now I do want A. I have put the right values in A. So I push enter and enter again, and I will have B. So it is correct. All right, let's go to the next one. Number 4, what is the multiplicative inverse for A when it equals negative 3, 2, 4, and negative 6? Okay, we can calculate the inverse on our calculator. Now by hand, yeah, it might get a little dicey, but don't worry about it. Let's do it with our calculator. Okay, second matrix. Now we need to go over and edit and put in our values. Okay, so push enter. Now it's open. We want to keep it a 2 by 2. If I didn't mention, you can change those 2's to any size. You can make it rather large, and the calculator will handle it. Okay, but for us, we need negative 3, enter, 2, enter, and then 4, and then negative 6. Double check that I pushed the right thing. Yes, yes, and yes. Okay, now remember, you have to use second mode to back all the way out. Now go to second matrix, okay? All right, in this situation, we don't need a function. We just need to select A, and it's already highlighted, so push enter. So now we have our A. We literally need to do what it says here. We need to the -1. So push X to the -1. Uh-oh. See what's happening? My pen is super sensitive and it's pushing stuff I don't mean. Now let's go back over. Okay, and that's what we want. We want that -1. All right, to the -1 power, I mean. Okay, so push enter. Now, it's a decimal form. It doesn't matter. It's not a big deal. Just push math and then see, we'll change it to fractions. Push enter, enter again, and there you go. So now we need to determine which one is valid. Well, A won't work because of this. I see that already. And B, same thing. And let's see, C, oh, that's not even the correct value right there. D, however, has this cell, -1/5, -2/5, and -3/10. Yes, option D is what we needed. Okay, let's go to number 5. Given the matrices, that is a typo. If matrices, that X should be a C. Okay, there we go. Given the matrices K, L, and M, which item below represents the value of K times L plus M? Okay, now, word of warning. I see option D right here. See, I noticed really quick, A, B, and C, they give us a number value. But D gives us this none of the above, the operation is not valid. And this is how you can catch that really quick and verify if it is or not. You must have, what I do is I say the top of my first one multiplied to my second one must have the same, meaning that K is first, then L. That means if you have 2 columns of K, you must have 2 rows of L. Okay, so those have to match 2 to 2. And I call it the top and the side or there's a lot of ways to remember it, but just in case you didn't, that verifies. And then there's another thing. When we solve that, or rather when we do this first part, K times L, it had to add, it has to be in the right form also. Okay? So when we put all this together, and I'm sneakingly suspicious now that I think it will, because this is what's going to happen. When we go to multiply that, it's going to end up being a 2 by 1 because you look at the other, like you do it backwards. I don't know how to say it. There's a lot of ways to teach that. But because we start with 2 rows multiplied to 1 column, it will become a 1 by 2, or rather, no, 2 by 1. I'm sorry, a 2 by 1. Okay. Anyway, it will be valid with RM. So let's go ahead and enter it. And we can verify it that way because if we get an error, we know something is amiss and to double check. All right, let's go about our business and give it a whirl. First, let's enter our KLM in our ABC. So I'm going to go ahead and write A here, B here, C here. Okay, it's going to be our ABC. All right, and let's get rid of some of my mess here so we can see what we're doing. Okay, all right. So second matrix, and we need to go edit. All right, and it's a 2 by 2, but we need to enter 2, 0, -1, enter, 4, enter. Okay, great. Now let's back out all the way. And second matrix again, arrow over, but this time we need to go down to B, highlight B, and enter. Okay, now let's see. That is not the correct value. It's the correct size matrix, but we need -2, enter, and 1. Okay, and again, remember, second mode back out, and then you go second, matrix, go to edit, and now we're going down to number 3 or C. Oh, see, my pen is super sensitive today. All right, I'm just going to push number 3, and there we go, and ooh, it's not entered either. So let's go down, and this needs to be 3 and -5, enter. Okay. All right. Now, second mode. All right. We need to multiply A, B, no, yes, it'll be A times B plus C, because remember, that's where we're putting them. Okay. So we need second matrices and push A, then times, then second matrix, arrow down to B, push enter. And let's go ahead and push enter again to see. We need to make sure that that is a 2 by 1. Okay, so push enter. And it is. And you know what? Let's go ahead and note what that 2 by 1 is. Okay, that way we can quickly verify when we add what it should be, because we're just going to add those together. Okay, so now I'm going to go back up and grab that, and I'm going to say plus and say second matrix, and I'm going to arrow down to A, B, and we wanted C. Okay, and I'm going to push enter. Okay, and that gives me option A. Now we can verify that right here like this. Well, -4 plus 3 is -1, and 6 minus 5 is 1. So there we go. Verified in more than one way. All right. And obviously, D would be invalid. I mean, we're okay. We're valid. Everything worked out great, and our sizes were correct. So our operation was valid. All right. This is the last question in this video. Thank you so much for watching again and making it all the way to the end of the video. You have great attention span and a lot of patience with me. Kudos to you. Thank you guys to if those of you who have shared our items, liked anything, and especially if you subscribe. That makes you the very best. You know what, guys? I wish you the best and happy testing.